Snowflake, DBT, Airflow, Kafka. Perhaps you heard of these tools. Together, these tools make a modern data stack. And imagine including all these tools in one project, one data pipeline, and including that project into your portfolio. That is a real game changer, and that's exactly what we're going to do today. We are going to build a real-time stock market data pipeline. Not a simulation though, but actual live market data. We're going to stream it in real time, orchestrate it with Airflow, store it in Snowflake, transform it with DBT, and get the life to the data with visualizations in Power BI. And by the end of this video, you will see a modern data stack in action, end to end, and you'll also have a portfolio project that actually stands out. So stick with me. Every minute you spend here actually worth it. And if you like the content, don't forget to follow. With that being said, let's begin.
Let's begin with the architecture of our project. Like any other data pipeline, our data pipeline also starts with a data source, which is an API, application programming interface, in our project. And that API will be FinHub, which provides a stock data for us. This data will be later streamed using Kafka as streaming engine, and this stream data will be pulled out and stored in an S3 bucket. Well, I'm not going to use an AWS S3 actually, but I'm going to use some alternative to that, which is MinIO, which performs identical to an AWS S3 bucket. So I'm going to use MinIO instead of AWS S3 here for the data storage, and this stored data will be pulled out and uploaded into Snowflake, and that Snowflake uploaded data will be initially in the raw stage, which is the bronze table, and then converted into silver, and then converted into gold. All this transformation, all the way from raw to clean data that is stored in silver, and business ready transform data that is stored in gold, all this data processing is done inside Snowflake using DBT as a data processor, and Snowflake is nothing but a data warehouse which stores the data. And then the process will be orchestrated using Apache Airflow. After that, the business ready data that is in gold table in Snowflake, we're going to use Power BI to connect to Snowflake to retrieve the data from there and create a dashboard in Power BI. We'll be using Docker to execute most of the tools here. So that is it with the architecture. And to begin with, we need the tools like Docker, VS Code, and we also need a Snowflake account. Basically, Snowflake provides a free trial for anyone. But for the first time, when you create the Snowflake account, they'll give you $400 worth of free credit that you can use. Let me show you. And you'll land in this home page. And here at the bottom, you can see the credits that are left. And it's been 6 days since I created this account. And you'll be granted with $400 worth of credits. And you also need Docker Desktop and Visual Studio. Firstly, let me show you how to install Docker Desktop. I'll post all these links for the tools in the description of this video, and also all the codes that I use will be uploaded to GitHub, and the GitHub link will be provided also in the description. Well, this is the Docker web page. Here, click on the download Docker Desktop, and choose which processor your computer is using. If you have AMD processor, choose AMD. If it's Intel, ARM. So mine is AMD. I'm going to download this. You know what? So it's like 500 MB, 500 megabytes. I'm going to cancel it because I already installed it. So that's where you have to download the Docker from, and then Let me install the Docker real quick. And make sure this checkbox is on. Use WSL2 instead of Hyper-V. This should be turned on, and then hit OK. And it takes a few seconds and get installed. We will be using Docker to run most of the tools in containers inside the Docker instead of running them on our host machine because it is more reliable and efficient. It's like uh, a virtual machine, VM. So it's like a virtual machine and it will run the tools in a virtual environment inside the containers. Now the Docker is installed. Let's close this real quick. Now let's install VS Studio. Download for Windows. Here as well, I'm going to cancel that because I already have the file with me. Let me just go to downloads. Path. And make sure you check this box, add to path, and then hit next, install. After that, finish. So let's install a few extensions, a couple of them that we need. On the left pane, click on extensions, type in Python. We need Python by Microsoft. I already installed it on my PC, so it shows uninstall. And we also need Docker. Again, this is also installed on my PC, but you need to install it as well. So we need that in our project. That's it with the VS Code. Now let's open command prompt. By the way, you have to have Python installed on your PC. And then you also need to install, you don't need to install. This is just for the convenience. It's totally up to you to install a virtual environment, but I install it to make it convenient for me. So all the tools that I use in this project, at the end of the project, if I want to uninstall all the tools, I don't need to uninstall one after another. I can just take the whole environment down. So the tools go out with the environment. Well, it says requirement already satisfied, which means I already installed it. But if it's the first time for you to install a virtual environment on your PC, it takes a few seconds to install. So we have that. And then now we need to initialize the virtual environment. For that, let me go to File Manager, C drive, users, username, create a new folder and name it something like real-time stocks, and let's say MDS, modern data stack. That's good. Now let's initialize the environment inside that folder. To do that, we need to go to that path. Wait, cd, copy that folder name, cd, and here we initialize it using Python -m venv space venv with full name venv. Now this initializes the virtual environment in that specified folder, which means you will find something like this inside the folder that we created, which means we initialize the environment here. Now we're good with this. Let's head back to, we don't work with this right now, we'll keep it for later, but now let's open the folder that we created. In here, let's create another folder named infra, referring to the infrastructure of the whole Docker. Inside the infra, we need to create a Docker compose, and it should be YML file. I'll show you how to create it. And this folder, all the files, and like I said, all the files and codes that I use here will be available in the GitHub, and the link is in the description. So we have this. Now let's save as inside our project folder, and inside infra here, let's name it docker compose dot yml, and file type to all files, and utf-8 as encoding. Save it. Now that is saved. Head back to command prompt. Head to cd infra. We're heading to the folder inside our project folder, inside the infra, where we need to initialize the Docker containers. Here, to initialize Docker, we need to run docker compose up stage. Well, the error here is I ran that command without opening Docker. We need to open Docker desktop first. It should be running in the background. Accept. We need to sign in first. Let me just sign in real quick. Let me pause the recording. I'll just skip it right here. So I haven't signed in, I just skipped it. So it should be running in the background. Now let's run the same command. Basically, the compose includes zookeeper, which we need to run Kafka, and we are initializing the Kafka container, and also calf drop, which is the UI that we use to spectate Kafka. And we use MinIO. We use the MinIO container for the storage. And then Airflow scheduler, which is the, like it says, it's a scheduler for the Airflow. And we need Postgres, and also Airflow web server, which is the UI. And all of these have their dedicated ports which are assigned. For the Kafka it is 9092, and also we add another port 29092. And for CalfDrop it's 9000, for MinIO it's 9001, 9002. All these are basically the default ports that are assigned for them. We can use different ports too, but this is the best practice to use these ports for that specific tool. So yeah, we are creating separate containers for every single tool. Here we mentioned Zookeeper, Kafka, CalfDrop, MinIO, Airflow Web Server, Airflow Scheduler, Postgres. And now the tools are downloading. Let me just pause it and now it says all the tools, all the containers for the tools are created. And when you see that and you open the Docker desktop here, extend the infra. Let me make it full screen. Here you can see all the containers created. Now after that we need to initialize the Airflow. You see right here they are not running continuously, they stop frequently. So to fix that we need to initialize that first. For that let's run docker compose. So we initialize that and then also docker compose. After a couple of seconds, they should be up and running uh, without any breaks. Okay. Now, after you see all of them running without any breaks, now we need to, by the way, I forgot to tell you something. In our compose file, we included in MinIO, we included the credentials here itself. These are the credentials. You can edit these credentials as you like. So you can replace this user like let's say J, and you can replace the password with whatever password you like. We did that for the MinIO inside the compose file itself. But for the Airflow, we need to set the password after the Airflow is initialized and running stably, which is now. So this is the right time to initialize. I mean, define the credentials for the Airflow because it is stable now. So to define the credentials, the username, I'm going to give it J. First name, also let be J. And last name, I'm going to say K. Role, admin role, privileges, and email, my email. and then password, and give a random password, the same password that I used for min.io, password123. You can put your desired username and your desired demographic information here, then hit enter. User J created with the role admin, so that is done. Let's see if all the containers are working now actually. So to access Kafka, like I said, Kaf drop is the user interface for Kafka. So we have to click on the Kaf drop port, which is the user interface for Kafka, this one. And next for the storage, min.io, we have to click on this port, min.io, and here username and password. Like I said, in the compose file it says admin and password is password123. You need to put that in. Admin password 123. Acknowledge. Here we can create buckets just like as in AWS S3. And now Airflow user interface is web server. You need to open that. Here we just created the username and password, which is J, and password is password123. This is the home page for Airflow, and this is for the min.io, and this is for Kafka, which is kafdrop. Okay, that is done. So most of the tools that we need are initialized now, and for the first step in our architecture, which is data source, we need to get the data source first. For that, you need to go to FinHub. If you haven't logged in to FinHub, you need to register first with a unique email, and then they will provide you with a free API key on the homepage, free API key, which allows you to do 60 calls per minute. This is the API key, and you need to get that API key to get the stock data out of this FinHub API. So we need this API key here. Okay, so that is done. And let's head back to Docker. No, let's head back to kafdrop. We need to stream our data into Kafka, right? So to do that, we need to have a topic created in Kafka. So we need to create a topic, and let's name it stock codes. So name it stock codes, and partitions 3 to manage the loads, and replication factor, just like I said in our last project, replication is about repeating your data storage locations. So it is basically about security of the data, and to reduce the risk of losing your data, you need to increase the replication factor. In our case, it's just a project, so we just leave it 1 as replication factor here, and the partitions as 3. And create that. Successfully created. Go back. Now the stock codes is created here. Great. Well, we have that. Now we need to, let's open VS Code. We need to create the producer code first, right? We need the producer code, and then we need the consumer code to pull the data out. Firstly, we need to create the producer code. For that, in the VS Code, head to search, and now click Control plus Shift plus P. like it says right here, show run commands, Control Shift plus P. You need to click that, Control Shift plus P, and you land on this one. You need to search for Python select interpreter right here. You need to select that, and it shows all the environments, and we need to select the virtual environment that we created. Right now we don't see that here because we haven't imported that yet. Let's just close this first. On the top left, hit on File, click on Open Folder, choose the project folder that we created in users, username, real-time stock, and yes. Now we'll find, yes, I trust the authors. We'll find the folders that are in our project folder. Now we need to head back. I said Control Shift P, Python select interpreter. Now we can see the virtual environment that we created, which is this. And it also says recommended. Now we need to click on this, the virtual environment that we created. Select that, and now we need to write the producer code first and then run it in the VS Code to get the data out of API and stream it on Kafka. Well, before creating the producer code, we need to install the tools that we need. Let's install them. For that, I created a requirements.txt file, which basically says lists all the tools that we need. Kafka Python for Kafka and Bodo 3 for S3, which is our storage. In our case, BinIO. So this is Bodo 3 is used to connect to the S3 bucket that we create in the storage account. And then Snowflake connector Python is to connect to Snowflake, and DBT core for the DB to run DBT, and DBT Snowflake to run DBT on Snowflake. And then we need requests. Okay, so we need to install all these requirements. So I listed all of them in the .txt file, and this requirement.txt is also will be available in the GitHub. Now to run that, you can run that on command prompt as well, or we can just go to here. No, let's just run that on command prompt. Command prompt. Right now we are in infra. We need to go back a little bit. So to go back, we do cd dot dot, and then virtual environment scripts. We need to run this file. So to run that, venv/scripts, and then activate. Now the virtual environment is activated. Here we need to install pip. No, wait. We need to first copy the requirements.txt file into our project folder. So let's paste it here. Because we activated the environment, we need to head back to the project folder, the root folder now, because that is where we pasted the requirements.txt. So to head back, we run this command twice. Now we're in the root folder. Now we have to write the command like pip install -r. We use that flag to read a text file. requirements.txt. This installs all the tools that we listed in the text file. Let me pause it and play it after the installation is done. Now the installation is done. So now our virtual environment is ready to run our producer code. So we need to write the code first. Let's open Python. I'll just do the imports in this text file in the notepad, and I'll do the rest of the process of extracting the data in the VS Code. Import requests from Kafka. Import Kafka producer. And now save this file inside our project repository, just here inside our infra. Let's create a new folder, name it producer. Yeah, and save it here. Name it as producer2, producer.py to specify it as a Python file, and also change the type as all files inside the producer file, and encoding UTF-8. Save it. Now inside our infra, we should see the producer right here. Right here. Now here we write the code. Firstly, we need the API key. We need to connect to the API, which is our data source, and we need to retrieve the data from there, and we need to connect to Kafka and then stream the data on Kafka. Yeah, that's it. And by the way, the data should be streamed in bytes. We have to convert the JSON file into bytes before streaming into Kafka. For now, let me just define the API key equals, and copy the API key, paste it in the quotes, base URL. For the base URL, I think I copied it somewhere. It goes something like, we just need to copy the base URL of this FinHub website, paste it. Then it goes like API slash v1 slash code symbols. For the symbols, we'll be doing 5 symbols for this project. which means five stock prices of 5 companies. And for the companies, let's choose the top companies that are on the stock list, which are a part of NASDAQ. MSFT. Tesla. Google. AMZN. Amazon. By the way, this base URL is it can be found in the API documentation in the FinHub. Should be somewhere around. I think it's the API documentation. Yeah, somewhere around here. I downloaded it. So that's where I found it. Well, you can use the same URL too. So I'm not gonna find it again. Now we have 5 companies chosen. We have the link. Let's define the producer. Producer equals Kafka producer bootstrap server and for the port read the ports that we specified in the YML. Since this is outside the Docker, since we are running this VS Code outside the Docker, we need to use this port to connect. So let's copy that. If we are running this code inside the Docker, we can just use localhost and the primary port. But now here we're running it outside the Docker. So to access it, we need to use host.docker because this is the host PC. This code is running on the host PC. So we're going to use that as our bootstrap server. Sure. Let's double that. Like I said, serializer. Just type in real quick. Lambda. JSON.dumps of. Here, the value serializer. Like I said, Kafka streams the data in bytes, not the JSON files directly. So here we're specifying json.dumps to convert a Python dictionary into JSON file. We use this method to convert a Python dictionary into JSON file, and then we encode it into bytes using encode UTF-8 to make it available to stream on Kafka. So this is the value serializer for that, and this is the bootstrap server where we connect the port actually. So it's like an address. A port is like an address for the tool to access. Let's create a function. use f strings and base URL. Token should be our API key. Set. So this is the whole URL. So at the beginning, we just defined the base URL that we need to connect. And this is the whole URL, which includes the symbol that we need to retrieve and also the token, which is the API key. So this is the whole URL we need to use to get the data, the stock data of that desired symbol from the API. And now for the exception handling, I'm going to use try and except method here. For the try response, create a response variable. I spelled it wrong. Yeah, response. Request dot get of URL. Response dot raise for status data equals response dot JSON of now should be JSON. And now we add two more columns into the data we're getting as a metadata, which means a data about the data we're getting. So in that we will include the symbol and also the fetch time when we fetched it, because the data we are getting from FinHub doesn't include the symbol. It just includes the close time, all the biographic data except for the symbol inside it. So we create a separate column to record the symbol as well. So we have to include data as symbol, data of symbol, symbol. Then data fetched at int of, remember we imported time. We imported time because you can use that module to get the present time. We use time of, which is the present time, and this retrieves the present time, not in Eastern time or IST. It's a UTC time, so the universal time. So this method retrieves the universal time, the universal present time in the UTC format. Did I say that right? I think I did. So we return data. And now, if we haven't got any data, we raise an exception. Except exception as E and print. So the machine lets us know it didn't get any data from that API. So for that, let's create an f-strings to display that error fetching a flower bracket to include a variable which is our symbol and is2 and flower bracket of E, which is the exception. That's it. And return none. Because we haven't got any data, we return none from this function. That's it. Now we connected to what? We connected to the API. We have the producer ready, which can serialize, which can convert a dictionary into JSON and encode it into bytes. We have that. And now let's create a while loop to iterate infinite times. So to create an infinite loop, we have to use while true method. So this iterates the process. This iterates whatever we say in the while loop infinitely unless something breaks it. It should be a human or it can be a command inside it. So we're not going to use any command inside it to break itself. We're going to break the producer by ourselves. If we want to break the stream, we can just close the command, the terminal, the whole terminal. So it terminates the code. In the loop, we use for symbol in symbols, which we defined the list that we defined at the beginning with our 5 companies that we chosen. And in that for loop, quote fetch quote of symbol, which is our function that we created. So we're passing each and every symbol once for the loop into the function to retrieve the record from the API. Right? So we got the record and we assigned the record to this variable, and now we need to create an if condition, if quote. We need to print what data we are injecting. We need to know that, so we're going to print that using f strings. I say producing a flower pack to include a variable, say quote, and that's it. Now we need to connect the producer to stream the data. Producer, and we are sending the data, sending the record that we have, which is stock codes, which is the topic that we created in cough drop. You remember this one? We need to use this. Just in case I don't do any spelling mistakes. Now we specify the value that we need to push, which is our quote, the variable that we got here. That's it. And we delay the loop for 5 seconds. And why 5 seconds? Because FinHub, for the free tier, the free key that we get, it only allows you to call 60 to have 60 calls per minute, which means we can use one call for every second, So we can do that. And because we are retrieving 5 companies at the same time, we cannot do that for every second. We have to do that for every 5 seconds because we are retrieving 5 records at the same time. So we have to make sure we are in the free tier limit. We need to retrieve one one record for all the 5 symbols once in every 5 seconds. I think I got it right. It might sound confusing. Let me show you. Time sleep 5. You know what? Instead of 5, let's say 6, just in case if that exceeds the given privileges for the free tier account. So I hope you got it. We are using a 5-second delay or 6-second just in case, just to be secure. So we are using that delay because we only got the privilege to call 60 records per minute, which is 1 record per every second. And we are calling 5 symbols, which means 5 records at the same time. So we have to delay that for 5 seconds to be inside the boundary that the API key given, the FinHub given to us. So that's what we did here. And let's save it now. Why is it red? So because now here, if we check for the syntax errors, I asked ChatGPT, and I did a few mistakes. And firstly, I did a typo here. This one right here should be capital K for the Kafka producer. And also, I did a mistake at here as well. Should be capital K, Kafka producer. Wait, Kafka producer. And also, here, I defined API key where EY is in small, where here I used API key where all of them are capitals, and here I used lowercase. So I have to replace these with uppercase as well. So that is fixed. And one more thing is I forgot to include a comma here. There should be a comma there. And that's it. Let's run this code now. And I forgot to mention, right now my account is under penalty. Let me close this real quick. Is under penalty, so they won't offer me the 60 records per second, 60 records per minute, because they penalized my host address, the host IP address. So to use producer in my PC, now I have to use a VPN to hide my IP address. You don't need to use that. Just because my host IP address is banned, I would say penalized by them, I have to use a VPN every time that I access the API key. So I'm going to use a VPN for that. Now it is connected. Now let's run that. There you go. So it is producing 1 record for every 5 seconds. So our producer code is ready. All we need to do is we have to check if the records is actually pushed into Kafka. To check that, you can go to Kafka, which is the user interface, and click on view messages inside the topic. Now it shows just one message because it takes time, right? It takes time to upload it to Kafka. Let's refresh that. Click on all messages. There you go. Now we can see all the messages. Let's go back a little bit. Stock codes. Head back to that again. Last two offsets. View messages. There you go. So all the messages, like I said, it doesn't include the symbol. We included manually right here at the end. We included a symbol and also the fetched at time. This is the time that we got the. Well, all these symbols, I asked ChatGPT. I forgot. So here it is. Well, C refers to current price of that particular stock, which here is Tesla's particular stock, and right now it is at 346.4, and this D is a change, absolute different from previous close. The previous day's close and today's no, the difference between the previous day's close and the price currently, which is 346, and DP is a percent change from previous close. It's the same thing like this, but it is in percentage here. And then H is the high price of the entire day, and L is the low price of the entire day, and O is the open price of the day. And PC is the previous day's close price, and the timestamp T is a timestamp of that particular stock symbol that we created, and fetched it that we created the timestamp of when the data is fetched. That's it. That's it with the data. Now we have the data streaming, which means we are done with this step as well. We have the data source, we have the data streaming on Kafka. Now our next step is storing the data in our S3 bucket, which is min.io console. Now for that, we have to create a bucket. Let's create a bucket named, let's say, bronze transactions. Invalid bucket name. Oh, I cannot use underscore, I guess. Let me see. Transactions. Oh, I cannot use underscore, but I can use hyphen. Okay, bronze transactions. Let's create that bucket. Now, the data in the stream will be pulled from the stream and saved in this storage. Well, that is that. You might wonder why we particularly used FinHub, because there are a few other APIs that can be even more efficient, but there is Yahoo Finances. Well, it is more efficient. It doesn't have any limits. We can do any calls, any number of calls per minute, but it is not official. The data might not be real. So FinHub is actually a real API. So this reflects the real data that is out there in the stock market. So I used FinHub for the realistic, for the to make the data realistic. And now we have the data streaming on Kafka. We need consumer code. To create consumer code, in the same way that we created producer code, we'll create a note. We're going to create a notebook, and we import JSON to deal with the JSON file, and we import Boto3. Like I said, Boto3 is to deal with the S3 bucket storage space, which is our min.io console here. So we need Bodo 3 to deal with the S3 bucket called storage space, and we need import time for time functions, and then from Kafka import, we need to import Kafka consumer this time, because it's a consumer code. We need to use the shit Kafka consumer. Let's just save it right now, and let's create another folder for that. New folder, name it consumer. Let's save it inside that folder, name it consumer as well, consumer.py, and the file type all files encoding UTF. Save. Now we can see that in VS Code. Oh, the data is still streaming. That's great. The VS Code under the consumer, here it is. Let's pull that and place it right next to the producer. Let's run that. And now, what would be the steps in consumer? I think I forgot to put the headings for the code. Let me just do that real quick. Say import requirements. To avoid confusion, define variables for API. Initialize. Initial producer. And this would be retrieve data. Looping. And streaming. Looping and pushing to stream. That's great. Same for the consumer. Import requirements. S3 equals go to 3.client. And we have to define the port. HTTP. The port that we assigned in min.io. localhost, and we are using 9002 to connect to min.io, the port. Now, this is the port that we're using to connect to our storage space. And like I said, the min.io storage executes identical to Amazon AWS S3. So we use S3 here as the client and AWS access key, which is our user ID for min.io, which we defined as admin, and AWS secret key is password123, which we assigned while creating the container right here, the user and password. Now we have the connection. Let me assign. Let me just put a heading for that. Oh, now that is done. Okay, let's specify the bucket name, which is the bucket name that we just created, bronze transactions. Let's just copy that. Now we assigned the connections for min.io. Now we have to define the consumer. Let's define the consumer with the variable consumer equals Kafka consumer, and our consumer, we have to consume the data. We have to get the data from stock codes, which is our topic that we created, where our data is. Comma. What am I doing? Bootstrap servers. The host name. For the host name, let's copy the host name that we assigned. Comma. name it bronze consumer. That's it. Now we define the consumer. For the Kafka consumer, we are assigning stock codes, which is a topic that we created in Kafka, which is this one, stock codes. And then we define the port that we need to connect, which is host docker internal 29092, which is in the compose YML file. And this one right here, we use this one to save the checkpoints. Like also the group ID is where the offsets are saved. When we run the consumer code and it saves the data that is on the stream, and let's say if that consumer code is interrupted for some reason and it has to run back, so when it stops and it came back operational again, it won't load the files. I mean, it won't get the files that are on the stream, which it already processed. It only takes the new files. So it needs to save the offsets, which are basically checkpoints where the process stopped. So whenever you run the code again, it starts from the point where it stopped. So that's why we use enable auto commit equals true, and we save those offsets in the group ID, which is bronze consumer. And this one here, you remember we used value serializer in producer right here. We used value serializer where we converted the Python dictionary into a JSON file using JSON dumps and encoded it into bytes using encode UTF-8. Now we need to decode it because the stream is in bytes in Kafka. Now to get that out and save it in min.io, we cannot save bytes, right? We have to save JSON files. So we have to convert them back again, which is deserialize that. To deserialize that, we do json.loadsof, which is basically converts, which is the other way around. Whereas JSON dumps off converts dictionary into JSON file. JSON loads off converts JSON into Python dictionary. It's the other way around. And we use vdecode to decode the bytes. Where we use encode in the producer, we use decode here to decode the bytes into the actual JSON file. That's what's happening here. And now we define the consumer. We have the min.io connection defined already. Now what else we have to do for the consumer? Now we have to pull the data and save it in the storage space. Before going to next step, let's use print here. So we will know if anything goes wrong in the top code, anything goes wrong in the code we've written so far, we'll know there's something wrong in the top part of the code. If this statement, this syntax, this string is not printed, we will know the error is on the top part of the code. That's why we do a print here, streaming, say streaming and saving to min.io, say 3 dots, like. Now we have to loop we have to get the data out of the stream and then store it. Let's say main function. We use a for loop, message in consumer, record equals message dot value, symbol equals record dot get of symbol, wait, ts, record dot get of, say, fetch that, int of time dot time of. Like I said, we use that method. Did I use? Yeah, we use the time dot time of method to get the current time that is in universal format, UTC. Put another bracket, correct? And we create a key using f strings, which is dynamic slash this is basically formatting the file name, the JSON file name. So our JSON file name will be a combination of symbol with the fetched time. And now the uploading part to the S3 bucket object. Capital B for this. Bucket equals bucket name, bucket name. Key equals the key we already defined. And for the body, JSON.dumps of. We're converting the dictionary again back to JSON file before saving it into the bucket. Dumps of the record content type equals application slash JSON. And now, yeah, that's it. So this is the main function. We're getting message. We're looping this function for every message in the consumer here. So every message in the consumer will loop through this loop, and we assign the variable a record with the message.value. Basically, a message in consumer gets one single record from the consumer, but still that single record also consists of metadata that is assigned to the data in the Kafka. So Kafka basically it assigns metadata when you stream data. So it automatically assigns a few metadata to it, like the timestamp when the record is generated, and timestamp of when it is retrieved. So the stuff like that. So we don't need that stuff. We only need the message that is inside that. So we to select that we use message.value. That's the value that we actually need, the data that is actually streaming. Okay, so we get that value and assign it to record, and symbol equals record.get of symbol, and we get the symbol out of that record, and the timestamp, the current timestamp, and then we create the key. We are just formatting the file name for every single record. So it will be unique. It will be a unique file name. So for that we do symbol with the fetched at time, combination of both, and then we push them into the S3 bucket. Put object, bucket name, bucket name specified already defined here, and the key, the file name, which is already defined here, and body json.dumpsoff. We did json.loadsoff here to convert to dictionary, and then here we converted it back to JSON, and then content type application JSON. That's it. So to make the code let us know it executed fine, it has to print something for us. Use f strings, use a dynamic string here, record for, include the variable symbol equals to s3 / the bucket name slash key, no, key, that's it. Let me check if we have any errors in this code. Now, here are the errors that I found. I wrote customer instead of consumer. Consumer streaming and saving email. And one more thing is I forgot a comma here. Forgot a comma. And that's it. Now let's run this code and see if it works. Because our producer code is already running in the terminal, let's click on the arrow right here and click run Python file in a dedicated terminal. This will open a separate terminal to run the code, while the producer is running on the other terminal. Consumer is running in this terminal. Oh, I just found out another error here. It just takes the latest files and it avoids the old ones, which means, let me just stop this real quick, which means it did something wrong with the consumer right here. Supposed to have offset reset equals earliest. So this one, it makes the code consider the old files as well, the old files that are saved as well. So without this, it just takes the new files that are coming in. All these files in the stream that are old will not be considered. So we have to use earliest here. Auto offset. So offset checks the earliest files as well. Now let's run this again in a dedicated terminal. Now it should save all the old files first and then come to the new one. Let's see how many files are actually in Kafka. 139. And min.io, if we refresh that, we'll see all the folders created, but it only shows one file for some reason. But there you go. Tesla has two. Google one, Amazon one. I think it's because my VPN, VPN makes my internet slow. I think that's the reason here. I just found out this happens, it gets stuck here because I already ran this code before, and this is the second time I'm running this. So the first time when I ran the code, it already saved the offset in bronze consumer. So the second time it assumes it already has the data with it. So I have to delete the group that is existing in the Kafka, or I can create a new one. So let's just create a new one, say bronze consumer 1 here. Now this should fix the error. Now delete this and run this again. Now all the old data and the new data will be saved. And by the way, I just stopped the producer code. I had enough data, so I stopped it. And also I don't want to run this VPN in the background. So the producer is stopped. For now we have like, not sure how many records we have. We have 139 records. That's fine. Now our consumer pulled the data from stream and stored it in the bucket. So let's check that out. Now refresh it. There it is. All the data that is saved in JSON format for all the 5 companies that we wanted. Now we have the data in the storage. Our next step would be transferring this data. In the architecture, we're done with the data source, we're done with the data streaming, we're done with the data storage now using the consumer. Now we have to pull the data out of the data storage again and store it in Snowflake in the bronze tier table. And then we have to go through the data processing step. Let's do that. And I think I already got all the files that I need. So let's just close this to save the computational power. Okay. For this part, we need to open the Snowflake account. Snowflake, home, the data. Let me delete this data real quick because I already created that before. Let me drop the whole database. Now it is dropped. Okay, in Snowflake, head to home. By the way, don't mind me getting more errors, a lot of errors. By the way, I just realized I've got a lot of errors while working with the codes. I know there are a lot, but while you're doing this project, if you don't want to get any of those errors, just download the codes from GitHub and run them because they're all tested and there is no way you get any error if you run that code. So just download those codes and take a look at them. They're just perfect. Well, for the next step, we need to, like I said, we need to uh, pull the data out of the S3 bucket and store them in the Snowflake. To do that, let's open the Snowflake first, the home page. Click on Create SQL Worksheet. Now we have to create a database and a table for the bronze. Create database. Stocks MDS. All right. And create schema stocks MDS dot common. This will create a database and also a schema inside the database. Let's run that first and see if it works. Syntax error. I used a colon instead of semicolon. Another error. Now run that. Schema common successfully created. Now when we refresh this, we will see a new database that we created named stocks MDS. I named MDS because we are using modern data stack. So I'm naming everything with MDS as a suffix. And a schema named common is also created. Now we need to create a table inside this. Create table bronze. Make sure it is inside the schema that we just created, this one right here. Make sure we selected our schema, which is stockmds.common. Make sure this is here. And now we can run this directly. Stocks. Quotes. Oh. V as variant. I think I typed it wrong. Right here, this one. This should work. Okay, now we created a table with one column as V, which is variant. Now when we refresh this, we can see the table that we created under the schema common, under the tables, bronze stock codes raw. Now the data we pull from the bucket, and for the next part, to pull the data out of the S3 bucket and upload it to the Snowflake, we're going to assign that job to Airflow using a Python code, and I already have the code written. Let me show you that right here. This is the code that I used. Well, I can't write the whole code on the camera because it takes a while because it's so long. I'm going to explain what we're actually doing here. So we're importing the requirements, and here configuration for the min.io connection, where it includes the port that we connect, and username, password, bucket name, a local directory where the data gets stored temporarily before it pushed into Snowflake. This is the folder name for that, and this is the configuration for Snowflake, which includes the username and my actual password, which is my temporary password. I'm going to change that password again. So this should be your Snowflake password, and this should be your username and Snowflake account. And this one, you can get this one from Snowflake. On the left pane, click on the username at the bottom, and then click on session details right here, Snowflake context. You have to copy this part and paste it here, just this part. And then Snowflake warehouse compute WH, which is the warehouse. And to find your warehouse name, you have to go to the admin, click on admin, and click on warehouses. You'll see all the active warehouses. And in my case, it's compute WH. It's mostly compute WH. So this is the warehouse that we're using, and yeah, we copy paste it here, and then Snowflake database, the database that we just created, which is stocks MDS. That's the exact name, stocks MDS. And under that, the schema name, common, Snowflake schema, common. That's the configuration for Snowflake, and this is the definition. Downloading from min.io. This is the function to download data from min.io. We use os.make directories, local directories existing. Okay. Endpoint URL, midpoint. We just assigned the variables before for the min.io connection. Here, we are actually establishing the connection using this and calling the variables that we are already defined. Min.io endpoint, access key, secret key that we already defined here. We're calling them here to establish the connection with the bucket, S3 bucket. And then objects. And here we're assigning the bucket, the contents, local files. We are creating an empty list for the local files and a loop. Key equals local path, host.f path, local directory, host.path first name. Well, we're just basically downloading the files and assigning to local files and then sending it to what? Yeah, that's it. We're returning the variable local files, which has all the data that is in the S3 bucket, and then here this is the function to load the data to Snowflake. And yeah, this is the connection configuration right here. It establishes the connection using the variables that we already defined at the top of the code. And in this loop, it accesses the staging table. So whenever we create a table in Snowflake, a staging table is also automatically created. It won't be visible to us, but it will be created automatically. So, and the name of it, we can access that staging table using this keyword @% and the table name, which is our actual table name. And then cursor.execute allows us to run an SQL code inside Python. And it says copy into bronze stock curts raw, which is our table, from the staging table that we already loaded the data into. And the file format is specified as JSON. That's what we did, and we printed that for the confirmation, copy into executed. And we close the cursor and we close the connection. And this is all for the Airflow. It basically says owner is Airflow and depends on past false. And then start date. This is the date that we need to specify when we are starting the Airflow, the orchestrated DAG file. So today's date is 9/9. So I'm going to change it from 5 to 9. So that should be the today's date. Retries equals 1. So if the code fails, if the DAG code fails, how many retries should it perform? So we are specifying one, just one retry, and then it says failed. Retry delay will be 5 minutes. And min.io to Snowflake DAG. Here we are calling the function min.io to Snowflake. No, we are calling the file name min.io to Snowflake. And schedule interval specifies the time interval. Now this is not every 10 minutes, this is for 1 minute. So this is for every 1 minute. It executes for every 1 minute if we do this. Or else we can say this, so it executes for every 10 minutes now. This means it executes for every 1 minute. We're scheduling it to run for every 1 minute. So catch up false as task 1 perform. Now the task 1 includes performing the download min.io function, which is the function that we defined here. So that is the task 1. And task 2 will be load Snowflake, which is the second function that we defined, which is this, load to Snowflake. And here we are defining the flow of the process. So first you need to execute the task 1 and then you go to task 2 that we are so that's what we're saying to do. Now let's just save this file, save as, and we have to save that into C users J infra. And when we initialized our Airflow, it creates a few files including DAGs, logs, and plugins. We have to save this file in DAGs because this is a DAG file for Airflow. Switch it to all files, say .py, and save. Now it is saved. When you save the file in DAG folder, it automatically be visible in Airflow, but you have to wait a few seconds until it refreshes. There it is. So it takes a few seconds to refresh. Now our .py file, which is our DAG, is visible in Airflow. Switch it to all. We need to activate it. Now, right when we activate it, it starts executing. So now it is running. We can see it here. And already one execution is already successful. And yeah, here this displays all the DAGs. And if you want to see the log files and audit them, we can go to here, browse and audit logs. This shows all the activities that are done in the Airflow. Now here it says running. It also shows uh, the successful run that is already done by the DAG and the time when it is successful, which is 5:19. Now the time is 5:19. The successful run was at 17:18, which is 5:18. And we can also check the logs when we click on the DAG here, audit log right here. Now it shows running. There is a successful run already. Refresh this. So there are 2 successful runs, which means we should be able to see the data inside our bronze table that we created. We head to data here, databases, inside our database, inside our schema, and the table that we created, this one. There you go. It shows 412 records already pasted. Data preview. There's all the data. So all the data is now inside Snowflake, which means we're done with this step. We got the raw data into the bronze table. Now we need to clean the data and store it into silver table, and then we need to transform the data, which is business ready, to be stored in gold. All this data processing should be done with DBT. To initialize DBT, let's head to C drive users, our username, and our repository, the project repository. Create a new folder and say DBT stocks. Now we are going to initialize the DBT inside this folder. To do that, let's open command prompt. Activate the virtual environment first. To do that, go there, copy that. Going to activate the virtual environment. Activate it. Now let's head back to DBT stocks. Right now the command prompt is in our project folder. Now we have to go inside DBT stocks, and here to initialize DBT, we have to run DBT init, DBT Initialize, and the folder name as DBT stocks. Enter a number. Which database would you like to use? It says Snowflake is number 1. In our case, it is Snowflake, so number 1. And account, for the account, we need to head back to Snowflake. And here, click on the session details. we have to copy the same thing that we used to connect the Snowflake before, just this part, and paste it here, and then your username, and select 1 to use password, and type in the password. That's great. And for the role, say account admin. For the warehouse that we already have should be on the left pane. Click on the warehouses, just like before. Copy the warehouse name, paste it here, and the database that we created, which is stocks MDS, and the schema is common threads, say 4. And now we're all set. We initialize DBT, which means if you open the DBT folder that we created, we'll see these 2 folders, and inside the whole, we'll see all these files, which means it is initialized successfully. Now, all the transformations that we do should be stored in these models right here. Here, we head to models. Now, first we need to structure. Let me rename that again. I don't want the capitals. Let's make small. I want to create one folder for bronze, another for silver, and another for gold. Why did I create a bronze when I already have a bronze table there? Because the bronze table we have here, we stored the data as a single line. We haven't structured it, we haven't parsed it in the right way. So all the data that is stored in there, the records that are only saved in one column, which is V, that we defined when we created that, which is V of data type variant, which is not structurally correct. We have to parse it accordingly and assign data types to that. So we created a view for bronze. We have to create a view for the bronze. That's why we create a folder for bronze, silver, and gold. Now first, let's create an SQL code for bronze. Before creating the bronze transformation, we have to define the source first. So like that, sources, name. We name the source as raw. Database, our database name, which is stocks MDS. By the way, this is not case sensitive. Our database, we can say we can write that in lowercase or uppercase, doesn't matter. So that's our database, and our schema name. Oh, not this one. This shouldn't be in capitals. Just the names can be in capitals. Schema, which is common. and then payable. That is our bronze table. So we are referencing the bronze table that is already in there in the Snowflake, and the schema and the database, and the source name is defined as raw. Now we need to save this. Inside DBT stocks, models, bronze, and say sources. Dot YML. Okay, we specified the source now. Like I said, now we need to parse the data. If you're wondering, let me show you what I mean. If I do select asterisk, which means all, from the table bronze stock codes raw. Now limit equals 10. If I run this, it should be limit 10. That's it, not equals. Now if I run this, see, all the data is just stored under one column, which is V, which we defined as variant. So it doesn't have a proper structure at all. Now we need to parse it. We need to structure this data. In order to do that, I'm gonna write a query here, but I'm not going to execute the query in the Snowflake. I will copy paste it in the notebook and execute it in the while we do the DBT run. But let me just write it here because it is convenient. Select V is to C. So we are selecting from the column V, selecting C, defining it as float as current price. So we are aliasing it with current price. And then VT float as change amount. Then VTP is also float as change percent. VH float as day high. Oh, they open. Previous day close. Timestamp as market. Timestamp is symbol, which is string as market. Market symbol, it's just a symbol. We fetched at fetched at timestamp as fetched underscore at, and we define the source from source of the source name that we created, which is raw, and the table bronze stock codes raw. That is it. Let's now cut it, paste it in a separate notepad, click on save as, head to bronze, it is in the bronze. Now name it bronze STG stock switch the type to all files, have the YML file UTF-8 save. Now we have the bronze. Now we do the silver transformation, which is cleaning. Unlike the other projects, we're not going to implement SCD2 or slowly changing dimensions or schema evolution in this project because we don't have to. SCD2, slowly changing dimensions, doesn't make any sense with the stock data. And we don't need to implement a star schema for this because all the data that is in the table is all related to one particular entity, and it should be compact, it should be combined, it should be enclosed, clustered in just one single table. We don't need a few other dimension tables to refer. That's why we are now going to use star schema and also SCD2. With that being said, for the cleaning step, because we are getting the data from an official site, we don't need to do a lot of cleaning. But if we see here, all the decimal values have a lot of decimal points. We can just clean them, or we can just change them to only have 2 decimal points. we can do that in cleaning. So yeah, let's do that. So for the silver cleaning, say select symbol, current price, and then we have current price, period symbol, period current price, and then what? We can do change amount. Yeah, let's do that. Let's go with the day high now. Let's round it up with day high, comma, 2 decimal points as day high, and round off day low it also should be 2 decimal points as day low, round off day open, comma 2 as day open, round off previous close, round it up to 2 as well, and say previous close. Change amount, can be same, but round off change percent as change percent. And lastly, we have these two, market timestamp, fetched at from REF, the bronze staging table that we just created. The name is bronze staging stock codes. Let me just copy the name. You can reference it using that, and say where current price is not null. Let me see if we have any errors in this. Well, I found a few errors right here. The total round should be capital. I left some with the lower cases. And also here, this should be lowercase c. And also here referencing, this should have a space in between the brackets, between the flower brackets and the parenthesis. Now that's perfect. Create a notepad, a new notepad, paste it. Now save it, save as, models. This is the silver transformation. And for the name, you can say silver, clean, stock, codes dot SQL. By the way, whatever the name that you specify here for the file name will be the name of your view that will be created in the Snowflake. And yeah, so we have this, save it. Now we have the silver table. Now we need the gold transformation, which will be our business ready transformation. Let's head to that. Let me close it real quick. Erase the whole query. For the goal transformation, like any other dashboard, we will be creating a few KPIs, right? And because this is about stocks, we will be creating KPIs for the current price of all the symbols that we chosen, all the companies that we chosen. So we're going to create a KPI for the current price for all the companies. So for that, we need a view like this. Select symbol, current price, change amount, patient symbol, order by, fetched at as rn from floor brackets space ref of silver, clean, stocks, codes, and space here. where rn equals 1. Well, we are selecting the symbol, the current price, change amount, change percent for the KPIs, and a few more charts. And now we are creating a view for that. In case you don't know why we are creating the views inside SQL, that is because in this project, we are going to connect Power BI with our SQL warehouse, which is Snowflake, using direct query method and not import. And when we use direct query method, it is always a best practice to create views inside the warehouse itself. So the heavy lifting is done at the database level, and Power BI will only deal with the visualizations. If we do the calculations in Power BI have to turn this calculation, the DAX code, into SQL and then run that SQL code in the warehouse and then get the output out of it. Because it is direct query, it should be live. The connection will be live and dynamic. So it is always a best practice to create views inside the warehouse itself when you connect Power BI using direct query method. And that's what we are doing here. And this is our first gold transformation query. So let's save it as, go back, gold. Let's name it gold KPI .sql and save. And for the next two views I'm going to create, they're big. They're so big. I mean, not so big. They're big. And if I write that myself right now and I explain it, it is going to take a while. So I'm going to copy paste that views that I already created, which one view is for the tree chart and the other view is for the candle chart. So I'm going to copy paste that code and I'm going to explain what we did in that query. Okay. I mean, I don't want to make this video lengthier. I think it is already a lot bigger than what I expected. So yeah, I have to make it faster. Now take this off. And minimize this, stocks. Have that right here, candlestick. This one right here. Well, the reference is already here. We took reference from the silver table, and then it selects the symbol cast market timestamp as date, which means it only casts the timestamp, which is a timestamp contains the date, time with the seconds. But here we are just taking the date. So we are just casting the timestamp as date, and we are aliasing that with trade date, and then we selected day low, day high, current price, first value over. We're partitioning the symbol by the date. We're ordering that by the date, so we get the latest value. No, wait. No. We get the old value, which is the first value. And here in the last value, we're going to order that with the time, but this time we're going to order that in the descending order, I guess. As date, ordered by market timestamp, rows between unbound preceding and unbound following. Well, basically we are getting the opening candle and the closing candle for the chart. And then candles here, it says minimum of day low, max of day high, any value of candle open, candle close. And from that candles, we're getting we're selecting all and partition by symbol, order by candle time descending. Then we're selecting candle time low, candle high, candle open, candle close, and a trend line to see the trend, to monitor the trend in the candlestick chart, which is a line drawn over the candles to see the trend. And we are making sure the candle chart only shows 12 candles on the chart. That's why we use this in this line. And that's it. This is the view that we created for the candlestick. Now let me save it inside models. No, gold candlestick .sql. All files, save. And also the tree chart. I'll close this. Yeah, the same thing. We're going to cast the market timestamp as date, just the time. We're just going to extract the date out of it and alias it as max day. And referencing from the same silver view that we created, and latest prices. Select symbol average of current price as average price. We're calculating the average price. And then join latest day ID, market timestamp as date, 1 day max day. And here we are calculating the volatility. Volatility is nothing but a measure of how often, how much the price is fluctuating for the given symbol or the given stock, the given company. We're going to calculate it using standard deviation. We're going to calculate the volatility with standard deviation. And we are also going to calculate relative volatility, which is nothing but making the volatility stay between the scale from 0 to 1, because the actual volatility would go anywhere from 0 to yeah, the actual value of the volatility would go anywhere from 0 to infinity. So we calculate the relative volatility to make the volatility stay in the scale from 0 to 1. And that is that. And now that's it. Join the all-time volatility, and yeah, this is the this is the view that we use for the tree chart that we're going to create. And now let's save this. Save as the same spot. Users, models, gold .sql at the end, and files, all files, save. Now we have all the transformation views, the queries for the views stored in the models right here. So let's just run the DBT. To run that, we need to open, oh, it's already here, open command prompt. And here, the actual DBT is initialized inside this one. So we have to go more deeper, which means we have to cd dbt stocks. Here we have to run the dbt here. To run dbt, we type in dbt run and hit enter. 4 threads, 7 models, and all the 7 models executed successfully, which means we should be able to see all the views listed in the Snowflake right here. We need to refresh this under the data and extend the drop down that says views, and you can see all the data here. The bronze data, the gold data, the gold candlestick, silver, all of them is here. Now we need to connect Power BI to Snowflake to get this data. And we're going to use, like we said, we're going to use direct query method here. By the way, we are getting the stock data of NASDAQ, which means we have to make sure you run the stream on the right time, because the NASDAQ stock market is only active from 9:30 a.m. to 4 p.m. Eastern time. If you run the stream when the market is closed, this what happens in my case. The volatility will be zero and the relative volatility will also be zero for the most of them, because the market is closed when I run the stream. And if you take a look at the data we have in silver, you see the whole stream retrieved the same current price. It never fluctuated. 237.88 for Apple. The same repeats every time. See here 237.88 and here 237.88. So that's what happens when you run the stream when the market is closed. So make sure you run the stream when the market is active. That is from 9:30 a.m. to 4 p.m. Eastern time. So now I have nothing to do. I just need to wait a few more minutes until the market opens and these values updated. That's what I can do right now. So I'll wait. And once you get the data, the actual data when the stock market is active, you can find something like this. This is real volatility and relative volatility. These are the values. To connect Power BI, let's go open our Power BI first. Here, click on Get Data From. Click on Database and look for Snowflake and hit Connect. And for the server name, go back to Snowflake. Click on Session Details. But this time we're going to copy the whole thing except for the HTTPS. And paste it here. And also copy the warehouse name. Paste it in the warehouse. Click OK. And if you're connecting to Snowflake for the first time with Power BI, it will ask for the credentials. Type in the credentials. Connect. Now it is connected. Now we can see all the databases that are in there. And under our database that we created, under common, let's import all the gold views that we created. They're all there, and select all of them and hit load. And here we are going to use direct query, like I said, to make the dashboard real time, to make the dashboard dynamic, change according to the new data that is arriving into the warehouse. So we're going to use direct query here. Click OK. Yep. Now we got all the data. And yeah, let's check on these views if they're correct. Now we have all the views, and yeah, the data is also retrieved, which means we're done with all the steps that are in our data pipeline, all the way from data source to connecting to Power BI. So the data engineering part is all finished. Now, if you're here for just the data engineering part, it's pretty much it. If you also want to create a visualization, it might not be so visually appealing, but I'm going to create a basic dashboard now. So if you also want to look at the dashboard, you can still stay, or I'll see you in the next video. Okay. Firstly, for the KPIs, let's create cards for the KPIs. Let's make it quick. I don't want to take too long for the visualization part. So for this, say current price. We create a KPI for current price. Is now current price, and we need to filter that because we're going to create 5 KPIs for separately for each symbol. So that we're going to filter just for the apple for the first one. That's great. Let's just edit this a little bit. Category label, turn it off, and title, turn it on. Title can be Apple, APPLE. Let's make it all capitals. Apple. Align it to the center. Color black, doesn't matter. Now that looks good. In the format, I think I have to change the format too. Yeah, that is it. So for this, where should I change the format? To change the format, we have to go to data format, custom, format code 0.00, which is 2 decimals, dollars, a dollar sign at the end. Looks good, isn't it? That's great. But the size is a little too big. Just reduce that. '20 should be fine. That looks visually appealing. Now copy paste it 5 more times. 1, 2, 3, 4. I mean 4 more times. Align them right next to one another. For the second one, edit the filter. Chose Amazon. No. Chose Amazon. That changes for Amazon. You know what? For the title, I should have just gone for FX, field value, and the field would be symbol. That automatically assigns Apple, the name Apple to it. So I don't need to do that for every other thing. Copy, paste, 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 paste. 1, 2, 3, 4. We don't need this. Remove that. Place that there, there, and there, and there. The next one for Amazon, and the next one for Google. Why isn't changing? Why the ID is not changing? I think I did something wrong here. Select it. Oh, I selected the first one now. Uh, that's unfortunate. Okay, let's edit that and say AMZN. AMZN, Amazon. This is Google. GL, Google. And this will be Microsoft, MSFT. And this will be Tesla, ESLA. Perfect. Now let's create a guard chart for all the KPIs, which measures the volatility, and put right under this one. And for that, the volatility is measured in the called the tree view. Select the volatility there. And this is the total volatility. It says sum. Okay. Now we need to add the filter again. Symbol Apple. Let's edit that a little bit. Data labels, target label. Okay, let's take out the title. Or just edit that title and say you know what, let's just name it volatility. Just turn the title off. This should be fine. Let's press it right here like this, and that align. Keep them aside for a while. Copy paste it, and that is for Amazon. Then Google. Copy paste it. Google. Then Microsoft here. space Tesla. Let's just align them real quick. That's good. And for the candlestick chart, click on these three dots, get more visuals. Well, Power BI by default doesn't have a candlestick chart, so we're going to import one. Candlestick. I would choose this one. Get it. Import successful. And now click on it. And for that, let's add axis should be the candle time, and candle close to the close, candle high to high, candle low to low, candle open to open. Come on. There it is. But here's the problem. The data we have, the stock market data, it shows the candle high, candle low, and candle open, candle close. They only refresh once in a day. And here I got two of them because I ran the code when the market was closed, which is the Monday data and the Tuesday data. So I got two datas. But if you ran the stream when the market is open, you'd only get one candlestick here. But I got two candlestick because I ran the data before even the market opened. So I got the Monday's data and the Tuesday data as well. In that case, yeah, in that case, if you want to get more candles, you need to run the stream for a few days, at least a couple of days to get at least two candles, or else you'll just end up having one candle. Now I have two candles here. It shows the candle close, candle high, candle low. Yeah, that is that. And just edit the title real quick. Candlestick. Align it to the center. Well, that is what we got, and let's do the tree map right here. For the tree chart, symbol as category, and relative volatility as, now wait, average price as values. There you go. And for the relative volatility, let's just edit the color to show them. For that, click on colors, FX, and let's use rules, symbol, choose tree, and choose the relative volatility, summarization sum. If value greater than or equal to, no, this shouldn't be it. No, sorry. The format style should be gradient here. And the field should be relative volatility, and the lowest value, let's change the color to red, light red right here. And for the highest value, shows the dark red. Now that should change. There you go. So the volatility, relative volatility increases, the thickness, the intensity of the color increases. And the size depends on how the current price of the stock, which is MSFT, which is a bigger stock price, which has a bigger stock price. That's correct. And now let's give it a little touch for the title too, and say tree chart. Like I said, I'm not going to invest more time on this visualization part, because this project is mainly focused on data engineering one. So I'm not going to waste a lot of time on analytics part here, but I'm going to do the basic chat. Just if you're so interested in it, if you're interested in creating a good looking interactive and a chart with a dashboard with more charts, you can take your time to do that. Okay, we have that. What else can we do? We can do one more chart. Let's do a column chart, clustered column chart, using change percentage and symbol. That should do. And for this, let's give it a little bit of touch to make it look good. For that, let's go to columns, all fx, here rule, gold KPI, change percentage. Greater than or equal to 0, or less than or equal to, say, 100. I'll leave it 100. It should be green. Perfect. And new rule, greater than negative 100 and less than 0, then red. What is this? Oh, this should be number. There you go. Now, this shows the change percentage of the symbol. If it goes up, the change is positive, it shows green, and if it is negative, it shows red. Now that is perfect. And for x-axis, hide the title. For y-axis, hide the title. And the title can be change percent, align it to center, and the data format can be percentage 50. What? No, that is not the way. Change can be custom. I'll craft it 0.00 and percent. know what? I'm gonna leave it. It's actually 0.64, 0.75. Well, it is what it is. And now, yeah, that is that. And let's add a slicer to filter the whole dashboard according to what we select in this slicer. To do that, we have to head to data model. We need to connect all these views to each other, drag the symbol from one view to the other, and then cross filtration should be both sides. Do the same with the other one. And cross filtration should be both. Perfect. Head back here. Now from any of the table, first create a button slicer, choose symbol column from any of the view, and now place it right here at the top. Let's test this. If we click on Google, everything filters just to Google. If we click on Amazon, switches to Amazon. Apple switches to Apple. Here you can see the candlestick clearly. So if you run the data for a few days, you can see multiple candles in this candlestick chart. You see that? Now that is looking good. And if we edit the buttons for the title, we don't need the title, I guess. Now anyone would understand that. The callout values can be aligned to the center. That looks good. Yep, that's it for the dashboard. And now let's have a recap of what we did. We started from the data source, and we streamed the data on Kafka, and we pulled the data out of the stream and stored it in S3 bucket, which is min.io UI, which we use. And then we pulled the data out of the bucket and stored in the raw table in Snowflake. And then we went from raw table, we cleaned it and stored it in silver, and then we stored it in gold. And this whole transformation is done using DBT as a data processor and Snowflake as a data warehouse. And we used Apache Airflow to orchestrate the transformation of the data from S3 bucket to Snowflake. And then we connected the data to Power BI. Now the whole pipeline is real time. You don't need to manually run the process. This is all automatic and it doesn't need any human intervention, which is why we call it real-time stock market data pipeline. And now we are officially done with this project, real-time stock market data pipeline, which is based on modern data stack. And I will be back with another exclusive project, probably on the modern data stack again. And by the way, if you like the video, don't forget to follow. And with that being said, until next video, adios.